Well, the long-awaited topic, imaginary numbers. So the first thing we're going to learn is how to deal with an imaginary number. First of all, an imaginary number, we use the letter I to represent an imaginary number. And I is going to be defined as the square root of -1. If we put it into our calculator, the square root of -1, the calculator will tell you that it is a non-real answer. Something that's not real is, of course, imaginary. So anyway, you deal with imaginary numbers just like you do with variables. For example, you all know that x plus x equals, hopefully, 2x, right? Well, same thing with imaginary numbers. I plus I equals 2i. Okay? Now what we're going to do next is we're going to look at, so we deal with imaginary numbers just like we deal with regular variables. So now what we're going to do is we're going to look at multiplying. So when you multiply x times x, you end up with x squared. So if we have an I times an I, we end up with an I squared. Well, the difference here is that I squared is actually a value, okay? Whereas x squared, we don't know what x is, so this represents some unknown value, okay? So we know from our definition that I is equal to the square root of -1. So if we square I, okay, if we square the left side and we square the right side, so squaring both sides, the square will cancel out the square root, leaving us with -1. So I squared is equal to -1. So if I did I times I, I'd get I squared, and I would say that is equal to -1. Okay? So let me get these squareds off here. Now, we know that I to the first is the square root of -1. I squared is -1. I to the third power is going to be basically I squared times I. Remember that when you multiply, you add the exponent. So 2 plus 1 equals 3. So I cubed is going to be equal to -1 times I, or -I. Okay? So I is the square root of -1. I squared is equal to -1, and I cubed is equal to -I. Now let's take a look at I to the fourth power. I to the fourth, we could do I squared. I squared times I squared, because 2 plus 2 is 4. So what we would have here is we'd have -1 times -1, and that's going to be equal to +1. So I to the fourth gives us +1. Then we go to I to the fifth, which we could take I to the fourth times I. And we know I to the fourth is 1, and I is just I. So I to the fifth, we're back to I, or the square root of -1. So these are good to keep in mind what these all represent over here. Now let's do some problems. So let's say that we have, example 1, we have 10i, and we'll square that. So we're squaring the 10, so 10 times 10, and then we square the I, which is I squared, and then we got to keep going. So this is going to be 100 times I squared, and we know that I squared is -1. And that's going to give us -100. as our answer. Okay? Now let's take a look at another example. And this time we'll do a simple binomial squared. So in this case, we're going to have 2 plus I times 2 plus I. Okay, so either you can FOIL this, where you multiply the first terms, the outer terms, the inner terms, and the last terms. Or we can use the box method. So 2 and I, 2 and I. Okay, so 2 times 2 is 4. 2 times I is 2I. 2 times I is 2I. I times I is I squared. Okay, so we're going to end up with 4. And then these are like terms. Remember, handle them just like you would a variable. So 2I plus 2I is 4I. And then we have I squared on the back. Now we have to do a little bit more because we know that I squared is equal to -1. So 4 plus 4I plus -1. And then we can combine these two. 4 plus -1 is 3. So we'd end up with 3 plus 4I. And this is our answer. And this is a complex number. It's complex because it has a real part. This is your real part, the 3. And this is your imaginary part right here. And when you have a real part and an imaginary part, you have a complex number. All right, let's move on to another example. Okay, so here this one's we have two fractions, we have a radical, so we have a lot going on here. So we're taking this binomial and we're squaring it. So I think what I'm going to do is I'm going to make my box nice and big. Okay, so I'm going to have -1/2 plus, and then we have I radical 3 over 2 times itself because we're squaring it. All right, so now we're going to do a little multiplication here. There's a lot going on. -1/2 times -1/2, that's going to give us 1/4. -1/2 times I radical 3 over 2. So remember, when you multiply fractions, you multiply numerator times numerator. So that's going to give us -I radical 3. And then 2 times 2 is 4. Okay, right here, numerator times numerator, -I radical 3. 2 times 2 is 4. And then here we have numerator times numerator, so I times I, we get I squared. And then we multiply radicals just like we multiply any other number. Radical 3 times radical 3 is radical 9. And then 2 times 2 is 4. So, first term, 1/4. These are like terms, and we handle them just like variables. This is going to be a -1/4 I radical 3 plus a -1/4. So a -1/4 plus a -1/4. So when you add fractions, the denominator stays the same, and you add the numerator. So we're going to have a -2/4, which we could reduce. We'll do it a little bit later. And then the I radical 3 just stays the same. Just like a variable. When you add variables, the variables stay the same. So the I radical 3 and the I radical 3 stay the same when we add and when we subtract. Okay? Again, let me repeat that. We added the fractions, negative 1/4 plus negative 1/4. We added those and we got negative 2/4. Okay? And then the I radical 3 stays the same. Then down here, well, we know that I squared is negative 1. So I'm going to go ahead and do that right now. I know the square root of 9 is 3, and that's all over 4. Okay? So what we have here is we have 1/4 plus negative 3/4. So 1/4 plus negative 3/4 is negative 2/4, which reduces to negative 1/2. So these two make negative 1/2 minus 2/4 reduces to 1/2. And there's your answer. And this is a complex number. This is the real part. This is the imaginary part. This is your complex answer. All right, I know this video is going long. One more example. Now, how do we do this one? Well, a couple ways we could handle this. We could immediately change I squared. We could immediately change that to what? Negative 1. Okay? We also know that I to the 5th is equal to I. But I'm going to change this problem just a little bit, I think, so that it's not quite so easy. Here we have I to the 3rd raised to the 5th power. So here I to the 3rd would be negative I. You could substitute right off the bat. But let's pretend we don't see this happening. So if you'll remember from Algebra 1, when you have a power raised to a power, you multiply. So this would give us I to the 15th over I to the 8th. And then if you'll remember from Algebra 1, when you divide, you subtract. So this would give us I to the 7th. Now, we want to evaluate I to the 7th. So, what I think I will do is I will use 4 and 3 to make 7. So I to the 4th times I to the 3rd, and I to the 4th is 1, and I to the 3rd is negative I. So this is 1, and this is negative I. And 1 times negative I is negative I. So the answer to this problem is negative I. Okay, I think I will stop there. I'm done torturing you for tonight. I hope you guys have a great night, and I'll see you tomorrow. Now that Jessica's here, I can help her with her question.